the first 4 problems on this assignment, we're asking you to first rewrite, because that's one of the main things with these antiderivatives, is just writing them into one of the forms that we need. And so when we rewrite this, we want to make this into our rational exponents. So it'll be x to the 1/3, and we have our antiderivative sandwich with the integral sign and the dx. And so now we can integrate this. So we'll add 1 to the exponent, and then we divide by that new fraction. And when we're dividing by the new fraction, it might be better for you just to think of multiplying by the reciprocal from the beginning. That just can be a little bit easier to deal with. But if you want to write it over 4/3, that's fine. But definitely thinking about when you're dealing with these fractions, you are always multiplying by the reciprocal. And that'd be something worth getting in the habit of. All right, let's do number 12, where we have 1 over 4x squared dx. And on this one, you'll have the 1/4. Only the x will come up to the -2. So that's how we would rewrite this one. And then when we integrate this, we have 1/4, and this will be x to the -1, and we do need to divide by -1. And so this becomes -1/4 x to the -1 plus c, or the best way to write this is -1 over 4x plus c. For number 13, we have 1 over x squared of x dx. And what we should do for simplifying this one is think about this as being 1 over x to the 3/2 here in the denominator. Because there's an x to the 1 times x to the 1/2, so we can make that x to the 3/2, which makes this overall x to the -3/2. When we integrate this, we'll add 1, and it'll still be negative. It'll still be that -1/2, and we divide by -1/2. Or you can think of this as multiplying by that reciprocal, which would be -2. The best way to write this would be -2 over the square root of x plus c. But as long as you have this step here, that is fine. And then one more where we're practicing rewriting before we take the antiderivative. For number 14 here, we have 1 over 3x squared. And this is 1 over 9x to the -2. When we add 1 here, it's x to the -1. We need to divide by that -1. So this answer is -1/9 x to the -1 plus c. Or you can make this -1 over 9x plus c. Either of those would be fine for these. All right, now let's go. The rest of them is 15 through 35 odd. So here on this first one, we have a sum. So we'll just do them both separately. X will go to x squared over 2. 7 will go to 7x. And you can leave it like that, or you can write that as 1/2 x squared plus 7x plus c. I do prefer it with the fraction in front. 17. We have x to the 5th plus 1 dx, so we have 2 that we need to do. So this will be x to the 6 over 6 plus 1x plus c. So we can make that 1/6 x to the 6 plus x plus c. Number 19, we have x to the 3/2 plus 2x plus 1. And this will give us x to the 5/2 times, and we'll do the reciprocal 2/5. And this is 2x, that'll go squared over 2 and 1x. We have 2/5 x to the 5/2 plus just an x squared plus an x plus a c. On number 21, we have the cube root of x squared, which we'll want to rewrite this as x to the 2/3 dx. And that will go to x to the 5/3 and then multiply by the reciprocal. Number 23, 1 over x to the 5th dx. Let's rewrite this to x to the -5 dx. And that will go to x to the -4 over -4 plus c. Or we can make this -1 over 4x to the 4th plus c. So I kind of ran out of room there. Let me write that a little neater. equals negative 1 over 4x to the 4th plus c. And let's look at number 25. We have x plus 6 over the square root of x dx. And so we have, we'll split this up, x over the square root of x plus 6 over the square root of x dx. And so this first one will be x divided by x to the 1/2. So subtract those exponents. We have x to the 1/2. And then this will be 6x to the negative 1/2. And so let's do this antiderivative. We have x to the 3/2 times the reciprocal 2/3 plus 6 x to the 1/2 times its reciprocal of 2 plus c. So we have 2/3 x to the 3/2 plus 12x to the 1/2 plus c. And I know those numbers, they get a little tricky when you have things like the 6 in front, and then you have the x to the 1/2, and you need to multiply by that reciprocal. It gets easier with practice. Number 27, we have x plus 1, 3x minus 2 dx. So before we do this one, we'll need to FOIL. 3x squared minus 2x plus 3x minus 2. So we have 3x squared plus x minus 2. And this will be 3x cubed over 3 plus x squared over 2 minus 2x plus c. And we can rewrite that as x cubed plus 1/2 x squared minus 2x plus c. Number 29, now we get some trig. We have 5 cosine x plus 4 sine x dx. These coefficients, they just stick around. So the antiderivative of cosine is sine. So we have 5 sine x. And then the antiderivative of sine x is negative cosine x. So this will end up being negative 4 cosine x plus c. For number 31, we have cosecant x, cosecant x, cotangent x, minus 2x. And so this cosecant cotangent, that is negative cotangent x, and then minus 2x squared over 2. That was just a power rule. And we can simplify this to make this negative cotangent x, and then just a minus x squared. The 2's will cancel. Number 33, we have secant squared theta minus sine theta d theta. The antiderivative of secant squared is tangent. So we have tangent theta, and then negative sine. Well, sine goes to negative cosine, and since we have a negative already, this just becomes plus cosine x. Oops, not x, cosine theta plus c. And then the last one on this assignment, number 35, we have tangent squared y plus 1 dy. Now, this one is not up in our list. We have secant squared, but not tangent squared. So what are we going to do? Well, take a look at your formula sheet, and you'll see that you have a trig identity that says that tangent squared, and I can't remember what variable it is, but tangent squared plus 1 gives you secant squared. And so we can actually replace with that identity, and you will have that formula sheet on your test. So we can replace that secant squared y dy, and secant squared goes to tangent. And so that's where, using your trig identities, you'll sometimes have to use those in order to do our antiderivatives here.